So, folks, we're diving into this wild news about Terafab, the $25 billion gamble that's set to completely shake up the semiconductor world right from the heart
Yeah,
of Austin, Texas.
absolutely. It's insane how Musk's vision, pulling together Tesla, SpaceX, and XAI, is aiming to handle everything from design right through to testing all in one place.
Right, exactly. Terafab is not just another chip factory, it's like a fully vertically integrated semiconductor marvel. We're talking about the whole process from lithography and fabrication to advanced packaging on one super complex roof,
Exactly.
and they've set an audacious target of 1 terawatt of annual computing power.
1 terawatt? That's astronomical compared to what we're used to, isn't it?
Yeah, it's like aiming for a seismic shift. What's really cool is how they've split the production between Earth-based edge inference chips, like those for Tesla's full self-driving tech, and orbital radiation-hardened chips meant to power SpaceX's Starlink network and even xAI's Grok infrastructure.
Yep, that's a bold strategy. So, essentially, 20% of production serves the edge, real time inference needs, and 80% is geared towards space based compute.
Right on. It's a two-pronged approach. The edge chips tackle those latency-critical applications, while the space-based compute chips are designed with tough conditions in mind, using solar energy and even laser communication links between satellites.
Yeah,
It's
that's
like
super
they're
futuristic.
rewriting the playbook for both terrestrial and orbital tech.
Now, I understand that this fab built in an old power plant in Austin is a sort of leap of faith, right? What are some of the implications in the semiconductor industry that this move brings?
Oh, lots of implications. First off, if Terafab scales, it poses a major threat to the traditional foundry model we've seen, with TSMC, Samsung, and Intel leading the pack. Basically, Tesla would move from being a big customer of these foundries to being a direct competitor. And the shift doesn't stop there. It's not just about more
That's a real
chips,
game
it's about the
changer.
whole chip ecosystem, including data centers.
And that leads us into the orbital data center concept, doesn't it? Moving compute to low Earth orbit sounds like something straight out of sci fi.
Right, and it's fascinating. By putting data centers in orbit, they're basically sidestepping two huge limitations: power issues and thermal management problems that plague terrestrial AI infrastructures. Imagine, space based solar power is practically unlimited, and the vacuum of space acts as the ultimate coolant.
Yeah, it's quite the vision. But, not everyone is buying into this dream, are they? Some experts are pretty skeptical about whether Musk and his team can pull off a 2 nanometer chip fab in just a few years.
Exactly. That's one of the major criticisms. Semiconductor fabrication at 2 nanometers is like arguably the most challenging manufacturing process ever. TSMC invested $165 billion dollars and accumulated decades of expertise. Starting from scratch in this realm is, well, pretty audacious. It's almost like
I get that.
expecting to build a rocket without any aerospace experience.
And speaking of experience, there's also the whole clean room debate. Terafab intends to ditch ultra stringent clean room protocols for what Musk calls wartime speed. That seems rather risky, don't you think?
Yeah, that's a major point of contention. Critics say it's insane, arguing that clean room standards are vital for yield management and for keeping the process under control. Musk, however, believes that deviating from these protocols allows for faster iteration. Personally, I'm a bit torn. While speed is crucial, skipping proper protocols might create quality and yield issues down the line.
Exactly, that's a valid concern. Right. Plus, there's the sheer scale of what they're trying to do, hiring over 6,000 specialized semiconductor engineers in a market where talent is already super scarce. Doesn't that put a lot of pressure on the industry and perhaps even spark a talent war?
Correct. It's going to be a massive talent hunt. The impact could ripple throughout the entire semiconductor sector, elevating wages and possibly intensifying competition globally. And let's not forget the geopolitical angle. Creating a domestic 2 nanometer fab might shift the balance, reducing US reliance on TSMC's operations in Taiwan.
Absolutely. Now, some critics have brought up that the $25 billion capital might not be fully secured yet, right? There's speculation about a future dilutive capital raise. How big of a red flag is that?
That's a big one. The fact that Tesla's capex doesn't fully cover this massive investment adds uncertainty. Investors might have to deal with a large capital raise down the line, which could disrupt market sentiment not only for Tesla, but also for SpaceX and XAI.
Yeah, that financial risk is non trivial. And then, if we consider the orbital computing part, manufacturing radiation hardened chips with efficient laser communications, isn't that still largely unproven at scale?
Precisely. The notion of orbital data centers is revolutionary, but it's filled with technical hurdles, hardening chips against cosmic radiation, managing temperature fluctuations in orbit, and ensuring robust data throughput via laser links remain big engineering challenges. This approach assumes that these problems are already solved, but, well, they are not yet.
Indeed, that's a significant challenge. So, while Terafab's ambitions are off the charts bold and potentially transformative, it's clearly a high-risk, high-reward venture that could either set a new industry standard or become a cautionary tale.
Absolutely. It's like walking a tightrope. If they succeed, it will rewrite the rules for silicon, data center operations, and even how we approach space tech. But if even one part of the complex puzzle falters, be it the manufacturing process or the painting by numbers of orbital compute, the whole venture could face monumental
That's the
setbacks.
gamble. Considering all these layers, the chip design, the manufacturing challenges, the supply chain implications, and the talent war, it seems like Terafab is a watershed moment for both the semiconductor and space industries.
Exactly. It's a blending of worlds that used to be entirely separate, the high-tech semiconductor arena and the cutting-edge space sector. And if it pans out, it might even inspire other tech giants to pursue
Yes,
similar
that
vertical
interdependency could
integration
redefine a whole
strategies.
ecosystem. One final thought. While the ambition is sky high and it's like trying to outrun the speed of light sometimes, do you think this could pressure the industry to innovate even faster?
Oh, definitely. Even if Terafab doesn't hit every target perfectly, the mere attempt could shift market dynamics, forcing established players to rethink, innovate faster, and maybe even adopt vertical integration tactics. It's like sparking a technological arms race.
It really adds fuel to the fire. Well, whether Terafab becomes the next big revolution or just a steep learning curve, it's clear that the semiconductor industry, and by extension AI and space tech, will never be the same again.
Absolutely, it's a thrilling time for technology. The only thing that's certain is that innovation never sleeps, and neither, it seems, do the risks.
Yep, no doubt about it. Thanks for the deep dive. This has been a wild ride through silicon, space, and everything in between.
Anytime, it's always fascinating to explore how a single venture can ripple across so many domains. Until next time, stay curious and keep pushing the boundaries of what's possible.